Hey, this is Ray Myers from OpenHands, and we're here with another community interview on AI and software development. And I'm really excited for this. I'm here with someone who's actually influenced my career a great deal, Emily Bache, a software developer and technical coach who has actually founded her own society of technical coaches called the Samman Society. Emily, would you introduce yourself? Tell us a little bit about what you do.
Hi. Yeah, I'm delighted to be here with you, Ray. You said already, I'm a technical coach, software developer. I spend my days helping teams to adopt better engineering practices, basically.
So, we've seen in the wild that AI has this impressive ability to write code, new code, sometimes maintain old code, but it has not necessarily reduced the relevance of testing. Many would say that it has even increased the need to focus on testing. There's been a bit of a resurgence of interest, I think very justly, for the notion of test driven development. So today I want to mostly focus on how you see that as a concept and how it relates to, the AI changes we've seen over the last few years. Let's start by introducing the terms. To you, what is test driven development? How would it be different than just doing some automated testing?
So, test-driven development is an approach to developing software. It's really a way of structuring the activities of design and coding and writing tests in tight feedback loops, taking many small steps and always having the software improve. It's more of an approach to development than it is really an automated testing approach. The tests are kind of a side effect of the way you're working.
Hence the name driven development, right? Rather than
Right.
just incremental testing or something like that. So, why does it do that? How does it help you when you test in this particular way create better software?
So I see it as an engineering approach. So engineering is about having a scientifically informed way to approach a problem, to break it into small pieces, to solve it in a way that is proportionate to the problem, and to end up with something that fulfills the needs of whoever's going to use it. TDD really helps you to break down that problem and to address it incrementally. Kent Beck talks about canon TDD, the essentials of the process. That first you think about the problem you need to solve and make a test list. So that's your first pass at breaking it down into pieces. And then you implement just one test from your list that fails because the thing doesn't work yet. Then you write the code to make the test pass. Then you improve the design, red, green, refactor. And then you go back to your list and pick the next thing. So you're continually working with just one failing test at a time. And you're always trying to solve one small piece of the problem. And you're always working on one aspect of the problem. Firstly, how do I write a test that will fail because this thing doesn't work yet? How do I make it pass? That's the next thing my brain focuses on. And then how do I make the design all work together? So it's this kind of interleaving of different activities in software engineering to solve a software engineering problem.
Could you explain just real quick what red green refactor means, just in case we have anyone who's not heard that expression associated with TDD?
Yeah, so it's red, green, refactor is this little kind of mnemonic to help you remember the three main phases in TDD. Red, write a failing test. Green, make it pass. Refactor, improve the design without causing any other test failures.
Great, great. You had this fascinating piece on the modern software engineering channel that you've recently joined, in addition to your own YouTube channel, which I really recommend. We'll link to these things. I wanted to ask how your view of TDD has changed over time, because you had this really interesting perspective in that a lot of people are talking about TDD's relevance in AI just because it will make the agent test its stuff, and you had a completely different argument for why you thought it was very relevant right now.
Thank you. I'm glad you liked the video and the explanation. I hope people will go and have a look at it. But the thing that I was struck by was basically TDD is a mental model. It's a way for me to approach development. And I kind of feel that it's when I'm working with agentic AI, one of these, tools in a loop, they are able to help with a lot of things, but the mental model of TDD helps me structure the way I work with them. It helps me to interleave these activities of writing code, writing tests, improving design. And I'm in control of the engineering. It is assisting me and augmenting me in those steps in my engineering process. And that's really the way I've been seeing these tools, actually. I'm a little surprised that that seems kind of novel, because that seemed to me kind of obvious that these tools don't do engineering. They augment my engineering skills.
There are a lot of different points of view, and I actually think what you've just said is probably the mainstream point of view on LLMs and coding. It's a helpful augmentation, but there are just all these sorts of tasks that you still have to keep an eye on and so forth. But it's not necessarily the most exciting view. Not to be too specific, but like, I think we can sell the value of these things based on what they are. I think that traditional dev tools are insanely valuable even when they're a piece of the puzzle, and we just have to find a way to make them the most valuable piece they can be. So I'm very much in line with you, and I'm pretty active in the space, but also it's like not the simplest and most exciting message. It's hard to make nuance exciting.
Yeah. Yeah, there is so much hype around these tools. And of course they're also changing really fast. So it can be a little bit dangerous to make some statement, oh, these tools can't do X, because in a few months maybe they can. But at the based on what they can do now, that's the way I think they fit into my process.
This is sounding like me being pessimistic about the space, but really what I'm trying to do is kind of refocus the AI tools. They must themselves be engineered. With every data store, with every type of technology we use, we leverage its strengths and we
Yes.
figure out how to use other components to work around its weaknesses. There are things that compilers are very precise at when it comes to manipulating code that LLMs are less so. Well, this is not a better or worse thing. We can fuse various technologies. I think the answer to LLMs lacking whatever they may lack at the moment, which I think necessarily includes judgment, for instance, which I think is a pretty core part of engineering over time. Given that, how do we make them the best, most reliable engineering assistants they can be, which I think can be quite a lot?
Yeah, this seems like a healthy way to take the discussion, because rather than talking about what they may or may not be capable of, what are these tools good at, and what should we be trying to use them for?
Is TDD a mechanical process that an AI agent could be programmed and prompted to do, or do you see it as a distinctly human process?
People have tried to force AI tools to do TDD. You can basically have one AI tool trying to do TDD and another AI tool kind of observing it and telling it, no, 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 you didn't refactor properly, go back and do it again. And so they kind of antagonistically force the other one to do a TDD process. And it's just so extremely inefficient and gets stuck so easily. It just doesn't really work. I don't think that's what we should be trying to get them to do. We don't want to get the AI tool to try and do TDD. I think it's not a helpful approach. We're the ones doing the software engineering, and we need to find ways to get them to assist us, enhance our judgment, not to make the judgments.
Yeah, that the judgment step. So yeah, putting this together with what you said in your video on modern software engineering, that this is all about mental models. You are using it as a way of kind of amplifying your thought process. And so it seems like it's almost unintelligible to you to say, okay, now let's just like have it do the thing that helps me think on its own without the helping me think part. Is that what you're saying?
You've put it very eloquently there, I think. Fundamentally, software development involves a lot of thinking and judgment and managing complexity, learning about the problem, learning about the needs of the users. And I think that these tools are pretty bad at those things. They're pretty bad at managing complexity at the kind of scale that we do in software regularly. And they're pretty bad at learning user needs. That's not really what they do. I don't think it plays to their strengths.
I'm somewhat close to your point of view on this, but it's still a hypothesis to me. I think a TDD agent hasn't really been tried because I think the examples you've talked about, I've seen, some of these attempts and some people who have very strong knowledge of TDD, like Llewellyn Falco have been able to get it working pretty well by using his knowledge in the process to coax chatbots and agents through doing this intelligibly. But we don't have an agent that like pushes you in that direction already, and people are trying to achieve the process by prompting. We're not actually getting into like how the agent is programmed around the language model, but the part of the agent that actually has deterministic logic in it. There are things that are possible about enforcing the process there. So there's kind of a hypothesis some people have that if we did that right, it would be helpful. But I'm closer to your contrary hypothesis that it would still defeat the purpose. Like over time, it would defeat the purpose of a thinking process if it wasn't also helping you amplify your thinking. I think maybe there's something that could be created, some hybrid that would be created that would be best of both worlds there. But I don't think anyone's designed that yet. I think we need to try things.
Right. So that's kind of a theme with all these AI tools. They're changing really fast. What they're capable of needs exploring. And a lot of the advice that people get is go experiment and see what you can come up with. I see my role as a technical coach a lot is not discovering the state of the art. It's to, once good approaches have been established by thought leaders, how do we then teach that and how do we spread that to lots of people? I'm also a big fan of Llewellyn Falco's work and others. And I've just as I said, I've been kind of following along behind, observing. And when they come out with something, oh yeah, now this is a good way to handle AI. Right, okay, how do I teach that to all the teams that I'm coaching?
I do encourage that. If there are any other people who have more, they're kind of walking the line in between principled and frontier, we could say. Are there any other that come to mind besides Llewellyn?
I mean, I'm part of the Samman coaching society. So is Llewellyn. We get together and we work on some pet projects using these AI tools and talk about the best ways to use them. So I'm kind of on the edge of some of these discussions with Llewellyn is collaborating a lot these days with Lada Kesseler. And I know that Nitzan Avni and Yvette Erdog have also got involved lately. They're some of the people who I'm looking to for what they're discovering about how to use these tools better.
Great. But of course, there's a reason that I'm talking to you right now, which is partly because what I tend to advocate is like, okay, you do want to follow some of the frontier stuff if you want to see how are people using these. But I think when people want to learn software craft, we understand how to teach that. It is still relevant. There are thought processes that you learn and apply there. Now, when you're using coding agents, you still understand the physics of what's going on. So at the moment, I think the best way we have to teach AI and software craft is to study software craft as a body of knowledge that already exists. Also, to study how to use coding agents. And if that sounds exhausting, I agree.
No, I think that's a good point, that the hard things to learn perhaps is test-driven development and the software craft, and those skills take longer to master than the AI skills, the specific prompting techniques and the patterns of interactions. So I think if you've got a limited amount of time to invest in your own skill development, that it's the software craft skills that will stand the test of time. And maybe I'm just biased, but it feels to me that you can, if you've got the basics of the engineering skills, then picking up the AI interactions and how to use it to augment your skills, that's less difficult.
Back to fundamentals on that note, talking about TDD again, a common reaction to TDD is that it seems like it would slow you down, like you're writing everything twice. But some people say TDD doesn't slow you down. How could that possibly be the case, that it doesn't slow you down when it seems to feel slow as you're doing it?
Yeah, this is a very common reaction. There's a couple of things here. I mean, one is that TDD is a skill, and it, like any skill, when you're learning it, you're not as effective at doing that thing as you were before. There's always a dip when you're learning a new way of working. So in the short term, yes, you will be slower because you're less familiar with the technique. But in the longer term, you've got to think about the fact that I think it's well established that you want to have tests for your code, that's a good feedback mechanism to have in place. Most software developers agree that they want to write automated tests. So they're going to write the tests anyway. So then the question is, why would it take longer if you write those tests first or interleaved with the development work? Overall, it shouldn't be more work. There's actually no reason why I think even in theory that it should take longer, unless you're writing, I guess, substantially more tests. But then you've got to balance that against the feedback that you get during the process and the opportunities you've got to change direction and improve the design and decide not to build that whole thing because you realize you didn't need it because the tests helped you to understand that. The more frequent feedback, in my experience, makes the whole engineering process more effective and efficient, and hopefully you'll get the right code written sooner. I don't really think it does slow you down once you know how to do it.
So learning is a big time investment, but that's, a one time per thing learned, right? Like I've definitely seen things where the reaction would be like, well, even testing this thing would take so long. And well, that's because we don't know how to do it. Typically, testing something you know how to test is pretty quick. Learning how to test something you don't know how to test might be slow. Okay, we can discuss that as a learning investment, not as an implementation cost. You can probably tell that I've had to have this conversation many times in my career. Have you found any other practices necessary to make TDD work?
Oh, yeah. I'm realizing you can't kind of talk about TDD as one skill that you learn once and then you can do it. TDD takes a long time and sustained effort to really master. I mean, months, years, a whole career really to get expert with it. I guess what I'm trying to talk about is the fact that I see TDD today, I see it as made up of hundreds of small micro skills. And that you go through a skill adoption process for each one of those micro skills. And you need a critical mass of them to be successful doing TDD in any given situation. For me, it's a part of becoming a better engineer and software developer is adding to my micro skills and expanding the range of problems where I can successfully apply TDD, this form of engineering, and raising the quality of the solutions that I come up with in the process.
So it sounds like understanding that when you get stuck trying to do TDD, it's always pointing at some kind of learning opportunity, and it's a matter of navigating what there is to learn. Because the rules are very simple, like chess, right? The rules are very simple, but all the ways that they play out in practice. So how do you go about that learning? Like, what are some ways you recommend people start with that? If they're like, okay, I've understood that I want to do TDD and I'm going to get really confused and I'm going to need to learn something. How do you integrate that into development work?
Well, this is one of the biggest questions of my whole career, really. I've spent, decades at this point trying to work out the
Figured I was
best.
right, asking the right person for this one.
Because I mean, I managed to learn this in a very optimal way on a greenfield project with a bunch of smart people all motivated to want to learn TDD and write good tests. And because it was greenfield, the number of TDD micro skills we needed was much reduced. There was no legacy, there was no difficult stuff. It was very much simpler situation to do TDD in than what I usually find when I go into companies and I coach teams. They're faced with legacy code, distributed systems, and all sorts of difficult situations to apply TDD in. The point is you've got to start somewhere, and you want to start on a simpler problem probably than your typical production code. So I'm a big fan of code katas. And a code kata is a small coding problem. I mean really small. And the challenge of it is not to get to a working solution. The challenge of it is to solve it using TDD and train your skills at breaking down the problem, making a test list. How do you design a failing test when you haven't got the code there yet? Then how do you refactor successfully when you've got something that works? And so you start to train some of the micro skills in a much easier situation. So for the people I've met who've successfully adopted TDD, almost all of them will say that they have practiced on code katas. The other thing that most of them say is that they've pair programmed on production code with somebody else who knows TDD or is actively trying to learn TDD at the same time. Because that kind of pair programming, you kind of double your chances of one of you knowing the correct microskill for the situation you're in. So you can kind of compensate for, like, we've got this bit of legacy code, how do I write a test for this? And then maybe one of you knows. So that's typical that the people who get good at TDD practice, they pair. What I've been doing more recently, the past few years, of course, is technical coaching. And this is the best way I've found to introduce TDD and to reinforce TDD with people who are trying to learn it. Because it's a little bit more structured than just doing code carters or just pairing, because you've got a mentor there, your coach, who is able to feed you suitable code carters for the level you're at to train the microskills you currently need, and to sit with you in your production code. And when you get stuck and you're like, I don't know how to do TDD now, how on earth do you write a test for this? The coach can come in and support you to do that. So that's my current best answer is, if you want to learn TDD, see if you can get a technical coach. And if not, pairing and code carters.
Great. As we wind down here, this has been a great conversation. I'm going to give you a magic wand. No promises that any of the wishes will be granted, right? But we may have the ears of at least our agent team, and maybe other agent teams and other AI products out there. When we think about how using a coding agent could be more supportive of your effort doing principled software craft, I think we've all seen times when it's fighting my process. It should be helping me, right? Do you have any notion of what it would be for it to behave differently in a way that's sort of more supportive of the way you're trying to use it? I will grant you between 1 and 3 hypothetical wishes for this exercise.
Wow, this is great. So I think one of the biggest problems I observe with these tools is that they're good at generating code and less good at updating it and improving the design or extending the design. So I think I would like them to, firstly, be able to use deterministic refactoring tools so that they can actually change design in a way that it won't break. So they actually will move a method using a refactoring tool and not just delete it from one place and then generate it again in a new place, subtly different with bugs in. So they actually use the deterministic tools. That's one thing. Something that a lot of humans don't do as well, actually, is that even if people know how to use the tools, they don't necessarily know how to string together a bunch of atomic refactoring steps to achieve a larger design change. So I think that is something that I think that these tools could be taught to do that get them to first identify the target design they want to move to, then make a plan of these are the atomic deterministic refactoring steps that I need to do in order to achieve that target design, and then use the deterministic tools to get there. I think that would really help the tools to be able to improve existing code without breaking it and without rewriting it.
I love it. It's very similar to something I demoed at Craft in Budapest. If someone is listening to what you're saying, like, okay, you're saying that there are algorithms that safely change code, and I should learn to string together a bunch of these so I can make this like mammoth code change without ever hand editing code. Okay, like, I know what you're talking about, but where would someone go and learn what that even means? If you have any recommended resources, I can link something by Arlo maybe, but what would you recommend?
This is a good question. I think a lot of developers have never seen refactoring done with tools properly. That's one of the things I've been trying to do on my YouTube channel, actually. Just show demos of me refactoring, achieving a larger design change through small steps, using tools, running tests frequently. Hopefully you'd find something on my YouTube channel where you can find a demo of that kind of thing.
Yeah. I highly recommend, your YouTube channel. It's very good. I've been making software quality YouTube videos for a while, and I am impressed, borderline intimidated by the catalog you've built up there. Any other advice you'd like to give, or other ways people can get in touch with you, engage with your work?
It's very kind of you to say so, Ray. Yeah, so Do find me on social media. Search for my name, Emily Bache. I'm sure you'll find me. And on the Modern Software Engineering channel, I also appear there. The Samman Technical Coaching Society that I founded has a website, and there's lots of resources there around TDD and refactoring and code cutters. And we've got a community of coaches and a newsletter, and you can get involved there if you would be interested. Maybe I'll see you at a Samman technical coaching event or something like that.
All right. Well, thank you so much for joining us, Emily.
It's been great being here. Thanks, Ray.